Today my topic is a solution of polynomial to calculate energy levels, and this is polynomial equation which I derived yesterday, and now how this can be solved is written some steps and you can go through, and though I will explain in detail. Then first is factorize the constant with sign, because here constant is -4. So factorize the constant -4 with sign. And second, rewrite the polynomial including missing powers of x, means this x missing power for x5, so I written as x5 with 0 coefficient, -6 4, xq is missing cube, so it is with 0, 9x square plus 0x minus 4. Like this we will write this algebraic equation, and then we will take one by one the factor, and we will assume that that factor is root of the polynomial, and then we will further discuss the solution. So this I hope that you have gone through, and now I am rubbing this. So this is a polynomial which we will solve, and factors are this. When we factorize this -4, these factors we will get, it can be -1 into 4 or -2 into 2 or 1 minus 4, like this. So we are taking these factors 1 minus 1, 2 minus 2. So this, first we write this polynomial and we write down coefficients with missing to 1 and plus 0 for x5, then plus I just minus 6 and plus 0 for power 3, and so this is plus 9 for x2 and plus 0 for x minus 4 is equal to 0. Let that first factor we choose as the root, and we try to solve this. So to solve this polynomial, we just put a horizontal line, and if we get here in the last 0, it means our this factor will be root of polynomial. So suppose we take 1, first factor is 1, we write down as such 1. This 1 into 1 is 1, so and adding we get 1. 1 1 is again we get 1, so here it is minus 5. 1 5 minus 5 is again minus 5, then we add, this is minus 5. 1 minus 5 is minus 5, then we get plus 4, and this plus 4 here we get, and if we again adding we get 4, and this 4, and here we get 0. We will ignore this 0, ignore this 0, and this is constant. Then we get another polynomial with coefficients, with these coefficients. Just suppose 4x square minus 5x cube. This is 4x and this is minus 5x square minus 5x cube. This is x4 and this is x5. This is new polynomial where constant is 4. This is with constant 4. Now this is reduced to x5 polynomial. Now this again, suppose we take, so here we will write down plus 4 With coefficients we can write 1, 1, minus 5, minus 5, 4 and 4. And now we choose another factor, say with say that factor is minus 2. 1 we will write down as such, 1 minus 2, this is minus 2 and here we get 1, minus 2 and minus 1 is minus 2. This will be minus 2 plus 1 plus 2 and here we get minus 3. Minus 3 minus 2 is plus 6 and we get plus 1. Minus 2, this here we get minus 2 and 4 minus 2 is 2 and 2 minus 2 is minus 4. Then we are getting 0. Then again this minus 2 is also a root of polynomial. So we have chosen, we are writing here roots 1 and minus 2. These are the roots. Now again we can, so again we get new polynomial. Ignore this 0, this is constant. So we get plus 2 and x. We write, again we write, this is plus 2 plus x minus 3x square minus x4 and x. This is constant, this is for x, this is for x square and this is for minus x cube and this is for x4. Now again we have come to from x5 to x raised to the power 4. Now again suppose we take the another factor, say minus 1, then in the similar way same procedure we will adopt. We will draw a horizontal line and now we take minus 1. So it will be in the form of 1 minus 1 minus 3 1 and plus 2 is factor, that constant. So we take 1 as such, minus 1 is minus 1 minus 2, minus 2 minus 1 is plus 2, this is minus 1 and minus 1 is again this minus 3 plus 2 is minus 1 plus 1 and this is 2, 1 and 1 2 and again 2 minus 2, that is we are got. It means our third root is minus 1 because we are getting minus 2. Now this is ignore this is constant and this is minus x minus 2 x square and this is x cube. Now this is in the form, this is next polynomial. Now the next factor is, that is 2. sorry, this is minus 1, we have taken this is minus 1, and now we take 2, 1 minus 2 minus 1, and now we are taking 2. So we write down 1 minus 2 minus 1 plus 2 constant. Again we draw a horizontal line and taking factor 2 as such, 1 is written as such, 2 1, it means plus 2, 0, 2 0, minus a 0, this is minus 1, minus 1, and this is 2 minus 2, and it is 0, and ignore this 0, and this is for, this is constant, this is 0x, and this is for x square. So we get that our equation is x square minus 1 is equal to 0. So in this way, this now here we get x square minus 1 is equal to 0. So fourth root is 2, and it can be, it is x plus 1, x minus 1 is equal to 0. So x implies that x barabar 1 and x barabar minus 1. So you can see that these 1 and 1 are repeated roots. So for these 4 and these are the repeated roots for this polynomial. So we have got 6 roots. Now with these roots which we have got after solving the equation, and this is again 1 and minus 1. These are our roots. So one by one we can solve the energy levels for the benzene. Now we calculate for the energy. As you know that x earlier in earlier videos I have explained that x is written in place of alpha minus E upon beta. So therefore this E is alpha minus beta x. One by one we will keep the values of this x and get energy level. Suppose first we take when x is equal to minus 2, then energy level is E1 is equal to alpha minus, this is minus 2, this is minus 2 beta, and this is alpha minus 2 beta. Next, when we take x is equal to minus 1, then as we know that we are getting two roots of the same number, that is minus 1 and minus 1. So here we also get two energy levels, and those are degenerate. Then E2 is alpha minus beta x is equal to alpha minus beta, and this is alpha plus beta, and this is alpha plus 2 beta. So this number is E2, and again we get at the same energy level. E3 is also will be alpha and beta, because minus 1 and minus 1 are 2 times. Now next is, suppose, now next root is x is equal to 1. X is equal to 1. So energy E3 will be alpha minus beta x, alpha minus beta x, and it will be alpha minus beta when x is equal to 1, and we are getting 2 times 1, so one energy level E4 will also be alpha minus beta, and this is the case of degeneracy. Now in the last we take with value 2, highest number, and this is E3, and this is E4, and this is E5, and this is E6 is alpha minus 2 beta, plus 2, it is with plus 2, x बराबर 2, तो alpha minus, and this is alpha minus 2 beta, and this is the energy level E6. Now if compare the energies, then how we will compare? That we know that experimental values of alpha and beta are negative. So suppose we are keeping negative here, then we will get alpha minus this minus alpha minus 2 beta. So we are getting this more negative, so this will be the energy level E1 is having lowest energy level. After that, if we see x बराबर minus 1, then again in both these cases it is minus alpha and plus, this is minus beta, यानी minus plus minus जो this is minus and plus minus, so we are getting 2 times minus addition, so we still get the energy with more negative but less negative to this E1. So E2 and E3 are more negative than E4 and E5, but less negative than E1. Similarly, if we compare this alpha minus beta, then minus alpha minus beta, because the experimental value of beta is negative, so here will be, it is minus alpha plus positive, so it is with it is with more energy, and this will be further with more energy. So our energy level will be like this. If we draw the energy level, so this is the energy level of non-bonding. This is when carbon atoms are non-bonded, so this is non-bonding. Lowest energy level, non-bonding, lowest energy level is this E1. We take this E1, and this is bonding energy, bonding molecular orbital. Further, it is alpha, it is alpha plus 2 beta, and little higher, this is E1, this is E2, and this is E3. This is again alpha plus beta, and this is again alpha plus beta. This is also bonding molecular orbital. And now E2, E1, E2, E3, this is E4, this is E5, E4 and E5. This is alpha minus beta, alpha minus beta. And these two energy and these two molecular orbitals are anti-bonding. Anti-bonding, and further at molecular orbital with highest energy is this alpha minus 2 beta, and again it is anti-bonding, and this is energy level S. So in this way we have got that 6 energy levels for benzene, where these 3 are bonding and 3 are not. Definitely lectins, 6 electrons, 5 electrons will fill this first, and here it is, and it is also in this way we get the energy diagram for benzene. Now we calculate the aromatic stabilization. Thus just we know, now if we calculate that pi electronic energy for benzene, then definitely E pi for benzene is that 2 electrons are in bonding, and that is alpha plus 2 beta, and plus 4 electrons in these orbitals, and this is alpha beta, and this is 2 alpha plus 4 beta and plus 4 alpha and 4 beta. Thus we get 6 alpha plus 8 beta. So actually benzene is having 3 double bonds, and if we compare it with ethylene, which is having single bond, and we take 3 ethylene molecules, that will be equal to benzene molecule. So for ethylene we have earlier calculated that E pi for ethylene is 2 alpha plus 2 beta. This is for ethylene, that E pi. Pi electronic energy for ethylene is 2 alpha plus 2 beta. But if for 3 ethylene molecule, is 2 alpha plus 2 beta is 6 alpha plus 6 beta. So but here also 3 double bonds and having 6 alpha plus 8 beta, and here 3 double bonds or 3 ethylene molecules is with 6 alpha plus 6 beta. Now we deduct this. If we minus E pi for benzene is minus electronic pi for ethylene is 6 alpha plus 8 beta minus 6 alpha plus 6 beta. It means E pi is greater than 3 ethylene molecules by 2 beta. And beta is having negative value, so this is 2 into negative. This means this negative value is making benzene is more that stable. So this is known as aromatic stabilization. This is known as aromatic stabilization. As we are getting here, it is 2 beta, and this 2 beta means that and this 2 we are getting this 2 beta extra, so it is for aromatic stabilization. So why benzene is more stable than other molecules of collection of 3 double bonds. So and so why that it is also very non-reactive. This is all about that solution of polynomial to calculate energy levels. In the next video, I will upload the wave functions for this benzene or molecular orbitals for benzene.